this lecture we'll continue our discussion on cloud services. We have already seen compute cloud service and storage cloud services. Today we'll see some other cloud services like application services and database services. So there are various cloud application services such as application runtime framework. The examples are Google AppEngine, Windows Azure website, then queuing service, Amazon Simple Queue service, Google Task Queue service, Windows Azure Queue service are example of such service. Then we have email service, Amazon Simple Email service and Google Email service are example of email service. Examples of notification service are Amazon Simple Notification Service and Google Cloud Messaging. Then media service, which is Amazon Elastic Transcoder, Google Image Manipulation Service, and then content delivery service, which is Amazon CloudFront. So let us look at what application runtime frameworks are, and then we will look into in detail in what is a Google App Engine. Application runtimes and frameworks. So cloud-based application runtimes and frameworks, they allow the developers to develop and host applications in cloud. So they provide all the necessary platform and the developing tools to the user to develop and host the application in the cloud so that it can be made accessible to all the users around the globe. Support for various programming languages available in such cloud-based frameworks. Application times, runtimes provide support for programming languages like example Java, Python or Ruby. Resource allocation. Application runtimes automatically allocate resources for application and handle the application scaling without the need to run and maintain servers. So this is one of the advantages that it handles the application scaling very well. So let us look at one such example which is very widely used and it is called as Google App Engine. So basically we know that Google App Engine is a platform on which applications can be developed and launched, that is hosted. So it is Google App Engine, or in short GAE, is a platform as a service implementation that provides services for developing and hosting scalable web applications. It is a distributed and scalable runtime environment that leverages Google's distributed infrastructure to scale out applications facing a large number of requests by allocating more computing resources to them and balancing the load among them. So basically it is a distributed and scalable runtime environment. Distributed because it is using Google's distributed infrastructure and it is scalable as it can scale the resources required to handle the requests for a particular application. The runtime is completed by a collection of services that allow developers to design and implement applications that naturally scale on App Engine. So this runtime, it has a collection of many services which we just saw. So for example, it contains image manipulation service which allows the applications to manipulate the image. It allows them to resize the image or crop, rotate or flip or enhance the image. So any kind of image manipulation can be done with that particular service. Then it also includes a service for authentication which can be integrated with, so basically Google Engine applications can be integrated with Google accounts for user authentication. So basically this runtime is completed by collection of services which the users or the developers can use to design and implement the applications. Then developers can develop applications in many languages: Java, Python, and Go. Go is a programming language which is specifically developed by Google for web development applications. Application usage of Google resource and services is metered by AppEngine, which bills the user when their application finishes their free quota. So this is the billing model. So there is a meter. So that means the services are metered and the users will be charged as per the consumption. So let us look at the features of Google App Engine runtime. So App Engine provides a runtime environment for Java, Python, PHP, and Go programming language. Sandbox. The applications will run in a sandboxed environment. That means an isolated environment. So application run in a secure sandbox environment, isolated from other application. This kind of environment provides a limited access to the underlying operating system. Data store. So Google App Engine provides a no SQL data store service. So SQL is a structured query language, and it is a standard language for creating SQL data storage, that is SQL data store, that is a relational data store. However, no SQL data store is basically provides a mechanism for storage and retrieval of data that is modeled in means other than tabular relationships, that is the one which is used in SQL data store. Authentication. App Engine application can be integrated with Google accounts for user authentication. Another application is a URL fetch service. It allows the applications to access the resources on internet such as web services. And the other services are email service, image manipulation service, memcache, task queues, and cron jobs. So email service, it allows the applications to send email messages. So image manipulation services allow applications to manipulate the image. Memcache service is basically a high performance cache service that applications can use for caching the data items that do not need a persistent storage. So cache memory is a memory which is a faster memory. That means accessing the data from that memory is faster, is much faster. So those data items or objects which are required frequently are put in the cache memory. Next is task queue. So basically, we'll see what task queue and cron jobs are and why are they required. But basically, what task queue does, it allows the applications to do work in the background by breaking them into small discrete units called tasks, which are enqueued in a task queue. And cron jobs, basically, cron jobs are scheduled task services. So App Engine provides a cron service for scheduled tasks that triggers at a specific time or at regular intervals. So this allows the application to perform tasks at a defined time or maybe at regular intervals. For example, sending promotional emails, and they have to be, let's say, sent periodically. So for that, a cron job can be scheduled. Memcache. So Google App Engine provides developers with access to fast and reliable storage, which is called as data store. It also provides caching services by means of memcache. So memcache is a distributed in-memory cache which is optimized for fast access. Thus, it provides developers with a volatile store for the objects that are frequently accessed. So the caching algorithm implemented by memcache will automatically remove the objects that are rarely accessed. So use of memcache significantly reduces the access time to the data. And developers, what can they do is they can structure their application so that first the object is looked into memcache, and if it is not found there, that is if there is a miss, then it will be retrieved from the data store and put into cache for future lookups. So basically this increases the speed of the application by providing faster access to the memory. Next is task queues. So let us understand this. So user and the applications, they are connected by means of web. Now whenever a user tries to access a web page and it submits a query or a task there, the task will be performed and the feedback will be sent back to the user. So that means this is the feedback of some computation which happened on the web application. Now, sometimes this approach is not applicable. It is not suitable. That is because if in case that that computation in the web application, it takes long time. It is very computation intensive request by the user. Then the user will have to keep waiting for the feedback, which is not a good policy. So this is not a good design policy for these kind of scenarios. Because users should be provided with immediate feedback. And once the task or the operation is completed, another notification can be sent back to the user. So Google App Engine, it offers additional services such as these task queues and cron jobs to simplify the execution of computation that are that are very computation intensive. That means they cannot be performed within the time frame of a web request. So let us look into this. So task queues allows the application to submit a task for a later execution. It is particularly useful for long computation that cannot be completed within the maximum response time of a request handler. The service allows user to have up to 10 queues that can execute the task at a configurable rate. So maximum number of queues that can be created would be 10. The queue is designed to re-execute the task in case of a failure in order to avoid transient failures, preventing the task from successful completion. So in case the task is not completed in the first go, it will be retried. So it will be re-executed. So this is the task queue. On the cron jobs, so it might be possible that the required operation which the user has submitted to a particular web page needs to be performed at a specific time, and it may not be at the time when the web request has been made. So then it is possible to schedule such an operation at desired time using a cron job service. This service operates similar to task queue but invokes the request handler specified in the task at a given time, and the important thing is it does not re-execute the task in case of failure. So this kind of feature, this behavior can be useful to implement maintenance operation or send periodic notification. So with this we have understood most of the features of Google App Engine. Next, let us see what are queuing services. An example of queuing service is Amazon Simple Queue service. So basically queues allows application to communicate by exchanging messages through queues. Amazon's SQS constitutes a disconnected model for exchanging messages between application by means of message queue hosted within AWS infrastructure. So what will happen is that there's a queue, application enters the message into the queue, and another application, it reads the message from that queue. Even while reading the message from the queue, there are two possibilities. That once an application reads the message from the queue, that message basically then becomes invisible. That means it will be taken down from the queue. Another option is called peeking. So in that, what happens? The application can read the message from the queue, but it remains visible. That means even other applications can access that particular message. So it is a queuing service from Amazon. SQS is a distributed queue that supports short messages of up to 256 KB in size. So this message size in Amazon SQS they have been upper bounded by 256 KB. So they're very small messages. So it supports multiple writers and readers and locks messages while they are being processed. Then it provides high availability. To ensure high availability, SQS trades off on first in first out capability and does not guarantee that message will be delivered in FIFO order. So if an application has entered some message into the queue, there is no guarantee that it will be delivered in FIFO order. And if the sequencing of the message is necessary, then some kind of sequencing information must be appended along with the message, so that the message can be reordered after retrieving from the queue. Next, let us see database service. So Cloud Database Service allows to set up and operate relational and non-relational databases in cloud. So examples of relational databases: MySQL, Oracle, SQL Server, etc. Non-relational databases that are generally provided by cloud are mostly proprietary solutions. So so most commonly used databases are relational databases, and they have been in use for quite some time now. Property of this kind of data store is that they store data in various tables, and these tables will be related to each other using their relationship across the tables. It will be easy to retrieve data from these tables. So that means the stored data in the tables, they have a relationship with each other. So SQL is the structured query language, which is a standard for SQL database, which has been used for SQL database for a very long time now. Whereas in non-relational databases, such kind of relation between various tables, so they don't structure the data in form of tables which are related to each other. But they can, these databases, they are very useful for block retrieval kind of applications which require to retrieve huge amount of data. Next is scalability. So cloud database service allows provisioning as much compute and storage resources are required to meet the application workload. Provision capacities can be scaled up or scaled down as per the user's requirement or demand. Then we know that these services or cloud-based data services are reliable, and they provide automated backup and snapshot options. Performance-wise, cloud database services guarantee the performance with options such as guaranteed input-output operations per second, which can be provisioned upfront. So it provides a quality of service guarantees on the number of access that can be made per second to the database. Security. There are various security level features which restrict the access to the database, such as network firewall and authentication mechanisms. So all of them are used to provide security to the user's database. Next, let us see Amazon's relational database. So basically, Amazon RDS is a relational database service that relies on EC2 infrastructure and is managed by Amazon. So in this, developers, they don't have to worry about configuring the storage for high availability or designing failover mechanisms or keeping the servers up to date, as all of this is done by the cloud provider. There are two advanced features of relational database. First is a multi-AZ deployment. So this option provides the user with a failover infrastructure for their relational database management system solutions. And this option, high availability option, is implemented by keeping in standby synchronized copies of the service in different availability zones that are activated if the primary service goes down. So basically, this is done by introducing redundancy and maintaining synchronization, tight synchronization among those copies. Then the second option is read replicas. It provides the users with increased performance for an application that are heavily dependent on database reads. So in this case, Amazon deploys copies of the primary service that are only available for database reads, thus cutting down the response time of the service. So that is, if it is taking a lot of time for this particular action, then it can be done in parallel. Multiple copies are created, and which are only for database reads. So thus the response time of the service reduces. Next, let us see what is Amazon's SimpleDB. So basically, it is a lightweight, highly scalable and flexible data store solution for applications that do not require a fully relational database model for their data. So SimpleDB provides support for semi-structured data, the model for which is based on the concept of domains, items, and attributes. So compared to the relational model, this kind of model will provide very few constraints on the structure of the data entries, thereby obtaining improved performance in querying large quantities of data. So if you see, the structure of data entry is very constrained in relational databases, wherever that is not the case in Amazon SimpleDB, which is a non-relational database. Moreover, this implements a relaxed constraint model, which leads to eventually consistent data. So we have discussed what is eventually consistent data. That means if there are multiple copies and one is updated, the others will be eventually updated. So that means it does not follow a strong consistency model. It follows an eventually consistency model in a distributed infrastructure. Finally, let us see what is a content delivery service. So cloud-based content delivery service includes content delivery networks. So what is a content delivery network, or CDN for short? It is basically a system of distributed servers or network that delivers the data or content, that means pages or web content, to a user based on the geographical location of the user and the origin of the web pages and the content delivery server. So basically, content delivery network, so there are a group of servers which work together to provide fast delivery of internet content. So it allows the quick transfer of the assets needed for loading the internet contents. They not only provide a faster experience to the users, but they can also prevent the site crashes in the events of traffic surge. So examples of content delivery services are video streaming, software downloads, etc. So let us understand, the need for content delivery networks or content delivery service. So let us say that a user in one part of the world want to access or download some software. Now, if that software is stored in a data center which is very far away from the user, that is, let's say, in another part of the globe, then the response time will be huge. On the contrary, if the user is able to download the software which is stored at the edge of the network, or at that means very close to the user, then the user experience will be enhanced as the software will be downloaded fast. This is because the propagation time has been reduced to a large extent. So content delivery service basically are very popular in video streaming. So content delivery network is a distributed system of servers located across multiple geographical locations to serve content to end users with high availability and high performance. So they are used for serving static content such as text, image, script, and streaming media. So CDNs have a large number of edge locations deployed in multiple locations often over multiple backbones. So let us try to understand this. So if we talk about the network can be broadly classified into 3 layers based on the geographical distance. They are called as local area network, metropolitan area network, and wide area network. Local area network is often called as access network. Metropolitan area network is referred to as metro, and this wide area network is referred to as backbone. So now if we look at the hierarchy of the network, which we have studied in data communication network, so we have access network, then we have a metro layer, and then you have the backbone network. Now, what is the edge location? Edge location means that router or that node of the network which is at the edge of the network. So any edge node has users connected to it, and so that means we can, if you look at the network, if we have many nodes, then the nodes to which the users are connected are called edge nodes, and the nodes to which no users are connected, they are called as core nodes. So in this, when the users request for static or media streaming, content that is served by CDN are directed to the nearest edge location. So this has hugely reduced the propagation delay. So obviously the streaming media or the content for whatever the user has requested for will be provided very fast to the user. So the examples of such content delivery services are Amazon CloudFront, Amazon Windows Azure Content Delivery Network. Let us look at Amazon CloudFront, some few points about it before we conclude the lecture. So CloudFront is an implementation of CDN on top of Amazon's distributed storage infrastructure. So what it does is it uses edge servers which are strategically located around the globe to better serve the request for static and streaming web content to reduce the transfer time. The content can be static or it can be streaming. That is either through HTTP, it can be downloaded through these protocols, or through real-time messaging protocols. The origin server hosting the original copy of the distributed content can be a S3 bucket, or it can be an EC2 instant, or it can be a server which is external to Amazon network. So whatever content the user has asked, it can be brought to the edge of the network either from a S3 bucket or from a virtual machine, Amazon's virtual machine, or any other service which is not within the Amazon's network. So it is necessary to create a distribution before the content delivery can start. Without creating a distribution, content delivery cannot start. What does it require? The origin server, which actually contains the original version of the content which is being distributed, should be referenced by a DNS domain name under CloudFront.net domain name. So once that content is referenced by a CloudFront.net domain name, that means the distribution is created, it is sufficient to reference the distribution name, and the CloudFront engine will redirect the request to the closest replica and eventually download the original version from the original server if the content is not found or has expired on the selected edge server. So Amazon's CloudFront. So it can basically enhance the improve the performance of a website in several ways. First, what it can do is it can cache the content at the edge location, and if there is some dynamic or interactive content, it can proxy that request directly back to the origin. So basically, to sum up, what do content delivery networks do? They basically cache the popular content on the edge servers, which helps in reducing the bandwidth cost and also improving the response time. So with this, we will conclude today's lecture, and we'll also conclude the topic that is services and platforms. So to summarize what we have studied in cloud services, we saw cloud reference model, and we saw various types of cloud services, and also saw specific cloud services which are offered by Amazon under these services. We saw what is a compute service. Then we saw, and in this we saw what is EC2 service, which is provided by Amazon. We saw what is a storage service and application service. We saw Google App Engine in detail. We understood what is a queuing service, then what are database service, and finally the content delivery service, wherein we also understood what a content delivery network is. Thank you.